Hello everyone, welcome back to our 100-day challenge. So today is day 7 where we are going to talk about Dockers. Yesterday we have talked about containers and containerization. So what exactly we are going to talk today? We are going to talk about what exactly the Docker is, why it is so important, how it is different than the traditional virtualization. Also we will learn about most important Docker terms that help us to understand Docker in more effective way. So without wasting time, let's get started. So friends, before starting today's session with the Docker concepts and the other aspects, let's check the knowledge related to containerization because this is the base of our Docker, right? So the first question we are having, what is the container in the context of software development? A physical storage unit for computer hardware, a lightweight standalone and executable package that includes everything which is needed to run a piece of software, a graphical user interface for managing files and folders, a type of virtual machine used for gaming. So you what you need to do, you just need to write down the answer of all five questions. I'll share the answers very soon with the explanation, but here it's about your knowledge check. So let's see how much you can make it correct. Next question we are having, what is the primary advantage of containerization? Increased hardware utilization, improved code quality, enhanced network security, or better user interface design? So this is the second question. Just write down the answer for this one. Next question we are having, which of the following is not a common use case for containerization? So I have already explained the use cases in my previous video for containerization. If you have not gone through, first go through that one. It is for microservices architecture, running legacy applications, continuous integration and continuous deployment, mobile application development. So which is not a common use case. Next question we are having, what is the purpose of a Docker file in containerizations? To run containers, to configure the host operating system, to define the instructions for building a container image, to manage container logs. So if you know the answer, just write down, otherwise you will get the answer in this video itself after going through this session. Next question we are having, which of the following is not a benefit of containerization? We have already seen the question for use cases. This is for the benefit, not get confused. So first is improved portability, reduced resource utilization, consistent development and production environment, efficient resource utilization. So these are the five questions you need to answer in the comment section. Check your knowledge, how much correct you are doing and how much you understood about the containers. If you still think that you need to learn containerization, then go to the day 6 where we talk about everything related to containerizations. Now let's talk about the first topic, what is Docker. So just understand this thing, we have already talked about the containerization, and we have also talked about the benefits of these containers. But the thing is, who will create these containers? These containers will be created by container runtime, right? So exactly, Docker is a tool, or we can say a container runtime that allow you to package and run application in a containers. Actually, containers are lightweight, self-contained unit, means which is having everything which need to be run a application independently. That include its code, runtime, system tools, and system library. Whatever this application is needed to run, it is having everything. So Docker makes it easy to deploy applications consistently across different environments. So that's why Docker is very popular in terms of container creation, container management. Is mostly it is used as a container runtime. Even in Kubernetes, we can use it. Now let's understand Docker in a single slide. So in this one slide, you will learn everything about Docker at high level. So Docker uses containerization concept, or we can say it's a tool which uses containerization or do containerization. So Docker allows application containerization, which provides a lightweight, efficient way to execute application with all their dependencies. This is just a short summary of what we discussed in our previous slide. Now let's understand what is the difference between Docker container and virtual machines. So as I already mentioned that when we are talking about the virtual machine, if you have not gone through my previous video, definitely you need to go through, especially for this one, to understand what is the main difference between the virtual machine and container, because I explained it in depth. But for higher level, a virtual machine, it's like a means it's do hardware abstraction. On the other hand, Docker containers is about OS layer abstraction. What does that mean? When we are talking about the virtual machine, it's a divide the host physical box or hardware box into chunks, and on top of that we create the virtual machine. On the other hand, containers is like it's a having host, and top of that if you are having OS, so it's like it's a divide this operating system and uses the chunks of these resources from operating system, but it is having the capability to utilize whole hardware box. So Docker containers run directly on the host machine's OS, which means they use fewer resources than traditional virtual machines. And containers don't need to boot operating system, but on the other hand, VM machine need to boot guest operating system. So this is high level difference, but you need to understand fully. So go back and learn that thing. Benefits of containerization, if we talk about containerization, allow application portability, faster deployment time, and better scalability. And containers work on the concept of build, ship, and run. You can build these containers, then you can ship it because these are very portable in terms of transferring or moving, and then you can run it on any platform. Why we should use Docker? So actually Docker allows for consistent and portable development environment, resource efficient deployment, and easy integration with other DevOps tools. That's why Docker is very popular since 2020. So these are the high level overview of Docker. Now let's talk about images. What are Docker images, Docker files, how the images are created, how the containers are created out of that one. So we are going into deep now to understand the underlying technology. Let's talk about the very important part because this is very important to understand when we are working in real time. Okay. So first we need to understand which platform Docker actually supports, right? So it supports Windows, Mac OS, and Linux. So all three these platform it support. Not only these, but also it supports most of the cloud platform which is available like AWS, Azure, or GCP. Also, we are having Docker Desktop and Docker Toolboxes, which are very popular installation options we are having. So these are the platform understanding where we can run our Docker, whatever system you are having out of this, you can try Docker on top of that. Now the thing is, what is the installation steps we need to follow? First, we need to verify that all the dependencies and prerequisites are followed on the platform which you are looking for. So for that one, you need to go to the Docker site and check that one. Then you can then run the platform specific installation package, just download and install it and verify the installation. How you need to verify the installation, I'll mention in this slide itself. So how you will verify? Once you have installed the Docker, you need to run few commands which will ensure that Docker is operational and working well. So you can either run Docker hello world command to test your application, or you can run Docker version command. So the command will be you can run Docker // version. So once you will run this command, it will show you the version of Docker which is installed on your system and the build. So there is a specific name, identity of that build that you will get it. So let me show you the demo now itself, but hands-on lab we will do in our next session. For the time being, you just need to learn how to validate Docker is installed or not. So guys, once you log in and created the instance from here, now you need to check that which edition or version of Docker is installed on this machine. So how you can do that one? You can do it directly here. This is the command to check the Docker version if it is installed or not. So this is the way you can check if your machine is having correct Docker version or not. So you can check this thing. It's like 24.0.2. This is the version and this is the build. So this is how we need to check if Docker is installed or not. This command will run on any platform where you have the Docker installed. For the more labs, we will go through the next session, but today just about checking the Docker version if it is installed on your machine or not. So guys, before deep diving into other topics, first understand what are the terms you can get related to the Dockers in our coming sessions. So it will be easy to understand. First thing is we mostly talk about the Docker images. So what exactly these Docker images are? So Docker images is like a snapshot, or we can say the executable package that includes everything which need to run a piece of software, including the code, runtime binaries, and the system tools. Once you run this image, then you will get the containers. So the thing is to create containers, you need to run some image. These images can be anything like Python. It can be based on your. So there are many images. We will go through the examples as well after some time. Next thing, you need to understand what is container. We have already talked about container is a running instance of a Docker image in terms. So what exactly the containers here? It's a running instance. That means we can perform the task on this one, right? We can stop, we can start, we can pause. It's like we can perform the task on this running instance. That is our container. Next thing, then what exactly the Docker file is? So the thing is, before building image, we need to have some file. Okay, that file will have some instructions. How this instruction will be, like you need to run this one, you need to use this base image, you need to copy this thing while running the containers, and what are the ports, everything, whatever you need to specify in this image, what exactly it will perform to create the container, that instructions we need to define in our Docker file. So Docker file is a text file that contains instructions for building a Docker image. It defines the base image, application code, dependency, and the configuration setting. So Docker. So first we will create the Docker file. Here we will write the instructions in simple language that I'll show you how to write it and what types of instruction it will have. Once we will have this one, we will run the command like docker build. Once we have that run this command, then it will create the Docker image. Once we will run Docker run command, it will run this image and will create container. So it will be like first step is to create Docker file. Next need to create image or build image. On third thing is to run container. Next thing, as I mentioned, we will create the images, but where it will be stored. So it will be stored in a registry. So what exactly the registry is? Registry is a storage system for Docker images. What it will hold? It will have Docker images. So Docker Hub is a public registry where you can find and share Docker images. Private registries can also be set up for internally. If you want private, like you are in a development phase, you just want to run and test, that you can use this private registry. Okay, so we can have two types of private and public. Private is related to yourself or some individual organization, but public is open for all. Next is, then what is repository? Okay, so a repository is a collection of related Docker images with the same name but different tags. What does that mean? And it will allow you to version and organize images for different purposes. Okay, so you are working on an image that will run some Python code. Okay, first time you build it. Okay, the version of this one is V1. You want some upgrade or modify something, next version is V2. Similarly, you work on that one, then next version is V3. So these all images will hold into a repository. Okay, so this is the repository. Next term is tagging. So whatever we are defining here along with the image name, so a tag is a label or version identifier for a Docker image. So with this additional information, or we can say the metadata, these tags will define that one. It's kind of a label. Next thing, Docker daemon. Docker daemon is like a engine, we can say Docker engine, which run in a background, and it manages the Docker containers and images on a host system. So whenever we need to perform these things like building image or uh, like building image, running any image or anything related to this one, related to Docker, it will be performed by this component, that is Docker engine. So it's kind of a brain of a Docker, we can say. So whenever now let's understand last term, then we will understand the relationship of this one. Next is Docker client. So what is Docker client? Docker client is a command line interface, as we already seen when we run a command of Docker version. So it's a command line interface that allow users to interact with Docker daemon. So whatever command we will write here in the command line interface, that command line interface is Docker client, but whatever command we are running here, it will connect to this one, Docker daemon. This Docker daemon will run those commands, and or we can say execute those commands to perform some task. So whatever command you will run, it will go through like this way, and it will use API for that. So this is how, and the important terms we are having. We are having different more terms also, but we will learn about that once we will go through that particular topic. So for the timing, you need to understand what is image, what is container, what is Docker file, what is registry, what is repository, tag, Docker daemon, Docker client, because these are the most common used terms while running or learning Docker or using Docker. So guys, that's it in this video. I hope you find this video helpful and understood little bit about Docker. In next session, we are going to talk about Docker architecture, where we will understand each component of the architecture, how those components works together. We will learn about the Docker images, Docker file, Docker networking, Docker compose, how we can run multiple containers as well. So till then, keep learning, keep exploring, and keep